All right, good morning. So I had some snafus with some fonts and some notes, so bear with me a little bit. But thank you for coming this early. So as you can probably tell from the title of my talk, it's based on some pretty painful personal experience. And I wanted to start today by sharing that experience with you. So in 2015, I worked at a small Tampa startup as a senior UI developer on a product team. And my main role was to build scalable, maintainable CSS architectures. The team and I had worked for months on a proof of concept. It looked a lot like a real app, but it was essentially vaporware. And we'd done well. There was a lot of buzz, and we'd snagged our first client. So it was time to get down to business and begin writing production quality code. It was an exciting opportunity to build an app from scratch, and we had decided we were going to do it in React. There's just one problem. There weren't any best practices for styling in React at that time. And this was really where the trouble started for me. Up until now, the team had been happy to take care of all the styles, to have me take care of all the styles, CSS, less, Sass. They really didn't care, as long as it looked good. But this all changed with React. All of a sudden, my 10+ years of experience styling applications meant absolutely nothing. And in fact, it meant that I was a dinosaur. And this was because in 2014, an engineer at Facebook gave a talk that changed everything. His talk made the case for putting CSS in your JS. And this really represented a shift from traditional MVC architectures to a more component-based architecture. And that shift changed the way we viewed styling in relationship to the rest of the code base. So the next few months, honestly, were some of the worst of my career. Every presentation, every conversation became a confrontation. Every conversation became a confrontation, and it was meant to shame and bully one side or the other into seeing the error of their ways. And by the end of it all, none of us were friends anymore. So if this sounds crazy, it was. And if it sounds familiar, I'm really sorry. But it didn't have to end this way. The team imploded not because of bad technology choices. In reality, most of the styling choices we tried would have worked if we just stuck with it. The problem was us and the way we approached the problem. We'd made things far more complicated and personal than they needed to be. If we'd been asking the right questions and really listening to each other, we could have avoided the whole mess. That was 2 years ago. A lot has changed. But the debate really hasn't. This is a recent Google search I did just for CSS. So I see the same arguments being made today that we were having 2 years ago. So I want to talk about that today and take a look at both sides of that argument, and then look at the pros and cons of each way that you really can style in React. So I'm going to look at both sides of the debate, starting with the gripes against CSS. We all know CSS is broken, right? CSS uses global scope by default. That is a no-no in JavaScript. Why are we doing it in styles? CSS dependencies and inheritance make style collision and overriding just inevitable. You're looking at separation of concerns all wrong on the CSS side, right? We look at CSS separation of concerns as a separation of technologies. And in CSS and JS, it's really a separation of components and what each piece is doing. And then the cascade, of course, causes thousands of lines of dead code and doesn't work with CSS at scale, so you have this dead code problem. But there are equally strong gripes against CSS and JS. CSS isn't broken, you just don't know how to use it. Using JavaScript to create CSS is excessive and unnecessary. Why are we reinventing the wheel? CSS works just fine on its own. CSS should be separate from your markup. The cascade is your friend if you know how to use it. And of course, oops. Apologies there. The cascade is your friend if you know how to use it. And of course, inline styles are a hack. So both sides, CSS and JS and the CSS side, have some pretty serious concerns about what the other side is doing. So now that we've heard the two sides, let's look at the options. You can break down styling into 4 basic categories, each one with its own sets of pros and cons. I'm going to start with the basics. Standardization methods, otherwise known as naming things intelligently. There are a lot of methods out there. Common thread among all of them is to eliminate style collision by lowering specificity and encouraging modularity. So standardization methods work with CSS, Sass, less, you name it. And in 2015, BEM was a standardization the CSS camp on the team was rooting for. And BEM stands for Block Element Modifier. Rules are really, really simple. Everything has a class, everything. Elements should never be directly styled, no nesting of styles. And choose clear naming conventions. And of course, you must follow the syntax religiously. So in this example, I have my friend component. Friend is a block. It's a standalone entity that has its own meaning and identity. Any DOM node in my friend block is an element of that block. They are semantically tied to that block and have no meaning on their own. So you would never use friend image or friend name or friend description anywhere else in your code base. It should always live inside that friend block. And a modifier is just an extra class name that can be added to blocks and elements to change its appearance or behavior. Modifiers should only modify the block, never replace it. And in terms of component structure, here's a simple component folder structure to start with. And I'm by no means telling you this is the way to do it. This is just one way that you can do it. I think component folder structure and structure in general is very personalized from project to project. But here we've got this simple structure. Each component should do one thing and do it well. And notice that each folder contains the JS, CSS, and test files. In this example, components have been broken out into 2 categories. So we've got our container components and just our components. The components folder represents our presentational components. They're stateless and they simply take props. The container components are stateful. They make API calls, et cetera, et cetera. There's a lot of benefits to this approach. You get better but different type of separation of concerns, and you get reusability in other projects if that's something you're concerned with. The presentational components also can be worked on by the design team without concern that it's going to affect the app's logic. So there's a lot of pros to BEM and standardization methods in general. I think they're a natural fit for building components. There's no configuration, compiler, etc. So we're using just straight CSS. Nothing to configure, nothing to set up and put together. Using BEM and presentational components, each component can be used over and over again in other projects. And single class names make collisions impossible and easier to rework as long as everyone's following that syntax. Rendering engines evaluate CSS selectors right to left, so the less there is to evaluate, the faster it's going to render. And I think that BEM structure lends itself perfectly to linting, so you can make sure that every style that is added conforms to the same standards. But there are some cons. Let's face it, naming things is really hard. It's probably one of the hardest things that we do. It sounds crazy to anyone that doesn't do this for a living, but I think most of my time building CSS architectures has been figuring out what to name something so someone else knows what I'm talking about. The rigid structure of BEM is what makes it work, but it's also, I think, what makes it difficult to write at first. It feels really weird. It doesn't feel natural, and when something doesn't feel natural, it takes longer. So it can be really frustrating to do something that you think you could do a lot faster another way, but you're being forced into this syntax and into this particular method. So you got to get team buy-in in order for this system to work. And losing the benefit of the cascade can be seen as a pro or con, depending on which side of the debate you fall on. The cascade can keep things dry when used correctly, or can result in a bloated code base where styles are repeatedly overridden and hacked. It's possible to use BEM for theming, but I would say that there are far better methods out there if theming is something that's important to you in the work that you're doing. And it may not be a serious con, but something about the underscores and the dashes when you first work them feels really, really ugly. And again, I think it goes back to writing something that's difficult or doesn't come naturally can make things a lot slower. So next I want to look at preprocessors. We're turning this into that. So a CSS preprocessor takes a language and outputs it as CSS. Syntax is usually more readable than plain CSS and allows you to write dry code faster. They contain a lot of helpful features like variables, operations, mix-ins, you name it. I think Sass is probably one of the most well-known extension languages, and so that's the one I'm just going to touch upon here in this talk. So the bad news about Sass, or any preprocessor, is that you still need to name things. So in this example, I'm continuing to use the BEM naming convention for our friend component. The friend component will look exactly the same as in the last example. Nothing changes here. The component itself is set. The difference here is that instead of having to write out each class in its entirety, we're nesting using the ampersand to assemble each class. We have variables in here, and there's a lot of ways that I could dry this up even further. Once compiled, the CSS output is going to be exactly the same as in our original example. And again, with the folder structure, nothing has really changed. We're still approaching each component as a whole entity. We're no longer separating HTML, CSS, and JS, and instead we're separating based on presentational components and container components. And in this example, I actually have the Sass outputting to an individual CSS file that lives within the component. However, you can do it a number of different ways. You could compile this into one style sheet and load that whole style sheet instead. So pros. There's a lot of pros to preprocessors. Sass gives you the power, obviously, of variables, mix-ins, nestings. It's got a lot of really helpful features I think a lot of us have grown dependent on. And in general, you can dry up your code quite a bit using these features. I also think a lot of them are really easy to pick up. If you already know CSS, there's no real overhead to jumping in and working with Sass. You can really do it straight away without much help. And similar to a first setup, each presentation component is modular. Each Sass file can be compiled into one sheet or can be exported into one single CSS sheet that lives with that component. So it really lends itself to working for your team and for the project the way you need it to. There are some cons. So to use Sass in your project, you'll need to add some configuration and dependencies. It isn't really a big con considering what we already do with Webpack and other things in React, but it's something to keep in mind. It's just one more layer. Nesting can get out of control very, very quickly. I've seen some devs new to Sass nest themselves, I mean, like straight to hell. They're like 10 deep and they can't figure out how that possibly happened. So you've got to be really careful with Sass and nesting. Having said that, I would argue that the component composition of React in general reduces the need for mix-ins and nesting. You shouldn't be building these really big components that do a lot of things. They should be very, very small. They should be very, very concentrated. And the amount of styling you need should be relatively small. So you may not even need those things. And you have to name a lot of things, right? We just don't want to do this. It seems to be a really popular refrain. So now I want to talk about inline styles. And inline styles are not the same as CSS and JS, and I'm going to get to that in a minute. And the first two methods that we just talked about have been standard for quite a long time. Adding CSS styles inline goes back even further. But in 2015, the idea of using them to style your entire application seemed kind of crazy. So just like it sounds, inline styles attach your styles inline to the actual DOM node. And again, they're not the same thing as CSS and JS, and I will get to that. But this is a same friend component. It's a simple example of inline styles. And this was the first example that the CSS and JS folks on the team brought to us in 2015. And I gotta say, we were horrified when we saw this. And to be fair, this is not how most people are using inline styles. Most are using style objects. It's much more maintainable than the first example. It's also the way React Native handles styling. Most will take it one step further and place the style objects in a separate document and then import that into the component. Sound familiar? Should. So, at the time, the thought for many of us was, seriously? You want us to style an entire application like this? The very thought of styling an entire app by injecting styles seemed laughable at the time. Because a big argument, right, had been working with CSS at scale. And from the perspective of the CSS folks, this was not scalable. The font size, color palette of the application had changed several times in just the few months that we were working on the proof of concept. How are we ever going to manage monumental style changes like that with inline styles? Surely there was an obvious need for global styles to handle things like font sizing, vertical rhythm, and color palette. Even more distressing at the time was learning what it couldn't do. And the main difference between inline styles and CSS and JS. So inline styles only supports a subset of CSS. CSS and JS, on the other hand, allows you to use all the power of CSS because it generates actual CSS. And we're going to get to those in a minute. I know I keep saying that, but we're almost there. So while inline styles are lacking quite a bit, I think there are some positives to them. Inline styles really forces you to change your mental model and see each component as its own entity. And this was something that it really did for me. I will admit that I was not against the idea of CSS and JS, but it did go against everything that I had learned, my years and years of best practice, and it really put my hackles up. But sitting down and writing a component and using inline styles really changed my view on that. I was able to see the component as its own concern and see the value in being able to localize those styles. And obviously, inline styles are the trump card in specificity, right? There's no way someone's going to accidentally override them or leave unused styles hanging around. And if you intend to stick with React long term to go React Native, your styles are still going to work. It's going to be much easier to move those over. So the cons list is a bit longer. So you'll need to depend on a library to access basic CSS features. And this was one of the big arguments from the CSS side at the time was we're just adding all these things that CSS does naturally. Why would we do this? And if you're not using a library, it's necessary to program JS workarounds to address media queries, pseudo-selectors, all of the things that CSS gives you just out of the box. And then again, depending on which side of the debate you're on, you lose the cascade. So you're not able to make global style changes using the cascade. Every component would need to be touched if the changes were going to be to go across all the components. And I got to say, it was really difficult to debug in the DOM. I did most of my work in the inspector. And when you're not using mapping class names to the elements, it's really difficult to tell what you're looking at. Even when you know what you're looking at, it's difficult to tell what you're looking at because the styles are jammed in with the rest of your elements. And interestingly enough, the components themselves don't really lend themselves to outside use in other code bases because you're placing these styles directly in line. You'd have to go in and reconfigure basically every single one by hand in order to use it somewhere else. And another interesting thing that we found was that performance was not very good. A page full of inline styles where each tag needs to be parsed is going to be less performant than loading a single style sheet. So CSS and JS is pretty hot right now, but in 2015, it was on fire. And in 2015, there weren't a lot of CSS and JS libraries, aside from Radium, CSS modules, and I think at the time that we were developing, like Aphrodite had just come out. Many of the cons that were plaguing inline.js could also be applied to libraries available at that time. And I think it's evolved quite a bit. So style components weren't around in 2015, but I think that they represent a giant leap forward in CSS and JS libraries. So I'm going to talk about that today. So here we have our same friend component. Should be very familiar with this component by now. But there's a big difference in the way we're putting this together. So style components actually utilizes tagged template literals to use real CSS and create normal React components. So as you can see, we're importing styled from style components. So we're importing that library, and then we're able to construct a wrapper component that applies the styles to a section tag. So wrapper equals style.section. In the DOM, that's actually going to generate a section tag with a mapped class name that maps to those styles. So it's a big difference in the way that you handle inline styles. It is not inline. It's actually generating a CSS style sheet. So at runtime, it's actually loading that into the head section of your document and then applying the class name to the styles. So I would say that how you structure your component folder is going to be a team decision. And in most cases should be decided before you ever touch the styles. In this example, I've actually broken that component down even further. Here, the way we've broken it down is we've constructed each piece, and then I'm just building in my render each piece of that component. Here, I've actually broken out each one as its own separate entity, and I'm bringing them into my index file. And that way, I can use these over and over again in other components and other areas and build like a bunch of Lego blocks, really. So this allows more flexibility and scalability long term, as you can easily move those smaller pieces around to construct larger components. So I think style components have a lot going for them. And CSS and JS libraries in general do. They allow you to write real CSS without context shifting between JavaScript and a set of style sheets. And it also enforces CSS best practices by removing that mapping between the HTML and the CSS. Because you're building small, purely presentational components, they're independent and reusable. And single-use class names make, there we go. Single-use class names make naming easier with no chance of collision. And of course, you have your containers and components, so you're separating out your presentational from your logic. Style components actually has basic Sass support, so you can do things with variables, nesting, mix-ins. There's a lot of really cool features there. It even has native mobile support and theme support. So there are some cons. Choosing CSS and JS as an approach means choosing a framework. So it's one choice followed by another choice. Glamour, style components, Aphrodite, CSS modules. There are many flavors of CSS and JS out there. And at the end of this deck, I actually have a resource that takes you to an entire list of all the possible CSS and JS choices you have. And it's yet another library to use, which I think is something to keep in mind because things change so quickly. Relying on a library that's the hot new thing today might be a problem later on. And it's also something that needs to be understood by the entire team. And I think a solid case could be made for the complexity this introduces. Many teams have designers and implementing styles and design patterns in CSS. So while a developer might be able to jump right in and feel very comfortable because this utilizes so much of what's already there in JavaScript, it could be difficult for others on the team. So the question is, what should I use? It depends. I know you're looking for one answer today, but there really is no one answer. I think it really does depend. There are a lot of choices out there. I think you need to start by asking the right questions. So what are the mental models on the team? A mental model is based on belief, not facts. It's a model of what users think or what users know or think they know about a system. And understanding each person's mental model of styling can help clear up misunderstandings and foster productive conversations. I think really having a good idea of how each person sees styling so that you can speak to their view on it a little bit better can help you in those conversations. And I think it's also important to acknowledge the differing skill levels on a team. So if there's a mixture of skill levels, as I said, a lot of times you have designers that are implementing your CSS and may not be as comfortable in JavaScript. Simplicity and clarity can really help everyone stay together. And if you're a group of highly skilled devs, then I think introducing complexity or new technologies probably won't pose that much of a problem. And then what do you need to build? Make sure you understand what you actually need to build. There's a lot of pressure in our industry to know the latest framework, the latest language, or whatever tech is making the rounds today. And it can be really tempting to jump on the latest technology. So before adding libraries and building complex styling systems to accommodate theming and reusability, make sure there's something you actually need. Start out as simply as possible and build from there. And then how do you plan on structuring your project? React is not opinionated about project structure. So understanding how you want to structure your project is going to help you determine the style method that's going to work best for you and the rest of your team. Will container components live separately from presentational components, or are they going to be kept together? Will you have the need for access to global styles? Is that something that you anticipate having to have? And these are just a couple of considerations. So think about these things before you jump into making that styling decision. Even more importantly, I think, is to create the right environment. Building things successfully requires more than the right technology. It really does require the right environment. And I think there are 4 ingredients to making that happen. First, avoid dogma at all costs. Taking extreme positions on a subject creates tension and defensiveness before conversations even get started. Build trust. Taking risks is really hard to do, and it's even harder if you don't trust the people you're doing it with. I think you need to embrace change. Whenever you feel the urge to push back on something, lean in instead, and you'll be surprised at what you'll learn and how many friends you're going to make along the way. I think lastly, you need to be vulnerable. It's okay to say you don't understand something or that you don't see the benefit in it. Being honest builds trust and opens the opportunity up for greater understanding for everyone on the team. And I think it's also important to remember, I love this quote, having a thoughtful understanding of CSS to begin with is going to help you build greater things. So whether you do it using CSS, Sass, Less, or CSS and JS, understanding what you're building and how to use it is very important. Thank you.